Today on RMB Racing, we unbox a new Haimer digital 3D sensor, put it up in the mill and use it to check out some vices and do a little review on it.
Alright guys, today I want to do another quick review. I want to go over another product that we have brought in the shop. I think you guys might be interested in it. So today we're going to go over the Haimer. This is to me it's the equivalent of a digital probe without having a probing system on the mill. You can purchase these, MSC has them, all your major suppliers, but we want to do an unboxing of it, and then we're going to mount it up in a tool holder. We're going to get it in the machine, and then we're going to use it to get the vices trammed in. So you guys are going to get to see it just like I'm getting to see it for the first time. We want to go over everything and let you see what this is. And going in, this retailed, I think, for just a tick over $800. I think $850. You see it a lot. I think we paid like $803 or $830, somewhere right in that area, low 800s. They do have a manual or a dial version that you can pick up in the $400 range. Main reason we decided to go this route, to put a probing system on the big mill was going to cost us in the $5,500 range if we did all the work ourselves. This gives us not a probe, but functionality similar to that, 800 bucks. And for us, the real big thing was we have the manual mill. We've mentioned it before, and this thing's really handy for manual mill. In the meantime, or for the foreseeable future, we're actually going to mount it up, put it in the tool changer, and use it on the big mill. But we're going to get to a point where we don't need it on the big mill, and we're going to end up loading it in and using it on the manual mill. So let's get started. Unlike the orange vices, quite simple packaging on this. Got a sleeve. Open it up. Instruction manuals, pretty much how to run it in, and the simple basic instructions on it. The test certificate for it, giving the dimensional accuracy of it. This is all in metric. If I'm remembering right, it's like a 0.5 thousandths accuracy, which is pretty good, especially for what we're using. We'll be using it for setting up fixtures, setting up holes, lining up on things, as well as just using it to touch off, finding our X, Y, and Z's. So I think that it'll do well for us for the accuracy. But we open it up, quite simple. Kind of hold it up there for you. And so literally we turn it on, and you can see it's set to -1 or -0.1. When we move it, it'll go up to 0. And so what the 0.1 is when you get to 0, it is the dead center line of this. It's accounting for the actual ball on the end here. And this is 3D, so it will measure pushing up on it and then in any direction around it. So it's three-dimensional. And you can have a metric or inch set up on it. Pretty simple. This one is I don't want to say waterproof, I think it's IP67. So it's safe with the coolant. You're not going to ruin it by getting coolant in it. So that was a pretty nice thing. The other thing I did check on is certification of this. If you're dealing with AS9100, ISO 9001, you're one of those style companies, you got to have calibration records. This is good calibration record, but you can send it back to Haimer and have it recalibrated and recertified. Also pretty sure most of your calibration facilities can do this as well. All right, so because of the accuracy we're looking to get out of this, I have a brand new Sandvik ER32 tool holder that we're going to mount this up in. have a brand new ER32 3/4 collet. The Sandviks are really nice because they got the bearing chuck in the top of them, which makes really nice. And then I've got a nice pull stud to put in here. So we're gonna get this set up. I didn't mention, I've got ER collets spread out on the table over here. We're in the process of getting a new bin system to hold all of our ER collets and tooling. Haven't gotten it yet, and I've already got these organized, so I'm kind of leaving them in place. I don't want them to make a big mess out of them just yet. So anytime you're going to use or put a tool together, you got to make sure you wipe and clean everything. Always use lint-free towels. These are lint-free. We're going to wipe everything down. All right, so anytime you put a collet into a tool holder, you need to see that there is, it's kind of off-centered. The reason it is, you take your collet and you stick it in on and lip it in on the fat side of it. Make sure I'm doing it right. And then it clips in. You can see it's held in there now. The collets, let me grab another one. Here is a ER50, and maybe you can see inside. You can see where it's really narrow here and it's a lot fatter up there. Those that don't have bearings in them have a much more pronounced lip on them. So we're going to chuck this in. I'm just going to start it in just a little bit. One thing I do need to make sure of is the orientation here, because the mill is going to chuck it into a certain direction, and I always want it to face me. So I need to make sure we put it in the correct way. I'm going to take a quick look. Okay. So we're going to spin it just like that. Try and get it in there nice and straight. And then we're going to torque it in. I like to use torque wrench to torque all of my collets. I just feel like you get a much better operation on it. You can buy these. This is literally a homemade tool, and I say homemade. We burned it out on CNC burn table. We designed them up in CAD and burned them out. This is one for ER32. Here's one I've done for ER25. There's one for ER50. Friend of ours, RPM Performance and Machine, he had designed those up and was going to machine them out. He asked me if I could burn them out, so I burned some out, and they worked good, so we started using them. Didn't have any issues with them. I do need an adapter because this is 3/8 drive. Okay. Obviously, we're not spinning this in the mill, so we don't need super tight, but we do want to make sure it's in there properly so that we can ensure it's accurate, concentric. One other thing I got to do is I got to put a pull stud in. So we'll lift this up, and I'm just going to hand thread it in there. I've already wiped this down and cleaned it up and gotten it ready. This is not a through spindle pull stud, it's just a standard one, obviously. I plan on leaving this tool set up so I don't need a through spindle. Coolant on it. And then I am going to put it in there horizontally just because it makes it a little bit easier. I pretty much put pull studs in just as tight as I can get them. Okay. So there's the assembly ready to go in the mill. Give me just a second. We'll get the mill turned on, fired up, and we'll get this loaded in there. All right, so we've got the Haimer mounted up in the mill, and I'm going to show you there's a procedure you have to do in order to set the concentrancy of the Haimer so that it's actually accurate with your tool holder. We've got a 8 thousandths indicator here. This is measuring in 1/2 tenth each indication. So pretty much you set your indicator up, put it on the end of the ball, and then we will turn. And as we turn, you'll see it start to come off. And this is actually not too bad off. It's reading about 1,000th out, something like that. Let me zoom in here. So you can get a better view there. Hopefully that'll help. All right, so once you've got that set up, they give you this little L-shaped Allen wrench, and you loosen up. There are 4 screws all the way around. You loosen those up. Now, once you've got them loosened, you then will use them and tighten one, loosen another, and you kind of push and pull it just a little bit until you get what you need. That definitely didn't go the right direction. Alright, so because I'm a perfectionist, I came back one more time and I wanted to make sure that I got it just as absolutely as close as I can get it. And so I don't know if you can see it very well now. But as I turn it, I'm literally getting less than a 1/2 tenth movement entirely. That is pretty awesome. And this indicator is calibrated and is accurate. So that is incredible. Took a little bit of time, but we were able to get all the runouts. So it's perfectly concentric now, or at least as good as you can really measure. So let's go ahead and reset this camera up and start squaring these vices up. All right, so we're ready to square the vices up. As you can see on our dial, we've got a negative 100 thousandths. That is so that when we push the ball, we'll want to get back to a point of 0. You can see that. So, and anytime you can move it, and you can always hit the on-off button. It resets it. And changing mode here changes from inch to metric. Anyways, I did double check on the accuracy of it, and they say that the accuracy is a repeatability within 4/10, and its actual accuracy is 4/10. So you can pretty much figure it's going to get you within 1/1000th of an inch, and you can kind of see that just from us using it. So we're going to go ahead, jog the Z down. I'm going to set the first vise up here, and I'm going to square everything off of it. So let's go ahead. Bring our Z down. Oh, I'm on the wrong one. Let's hit Z here. On our Y back. The hard jaws on these vices are a fixed location on the center. So right now the center is perfectly perpendicular with the vise. Okay, we're just going to drop that down below it. And we'll run it on up to 0 here. All right, and then I'm going to jog us across. I can already see that vise needs bumped. I'm going to zoom in so you can see this a little bit better. Although I have to say, considering I just roughly put those on there, you know, we're 15 thousandths. That's not too bad. 16 thousandths. Okay. This off again. So far we're out 1,000th. 3/1000. Okay, let's go. And here, thanks. All right, so we're less than 1/10 of run out on it. I'm gonna go ahead and bolt this vise down and kind of get it in place and just double check it, and then we'll square the next vise right up off of it. All right, so we've got this thing lined out, and we'll show you. We'll jump across. We're right now at 2/10. You can see we stay within 2/10 pretty much all the way across. 1/10. Kind of depends on which direction we're going, and I'll say that's probably less a issue with the Haimer, more of an issue with our meal. That's probably just inaccuracy in it. And then you can see we're at 7/10 all the way across. Now we're 0. So we're all over being within 1/1000th of an inch between these two vices, and I got to be honest, I think that's pretty good. I mean, it's yep, I think we're pretty good. So definitely like using this Haimer. All right, so we've shown you the Haimer, done the unboxing of it, got it in the mill, set the concentric of it, and set up a couple vices with it. So far, really like it. Really like how it works. It looks to be really accurate as well and pretty consistent. In fact, I think it's more accurate than what our meal is, which is just phenomenal. So if you got any questions, any comments, be sure to leave them down below. We'll maybe do a follow-up after we've used it for a while and kind of give you a little feedback on that. But for now, I think that's it. Be sure to hit the subscribe and hit that notification bell. Also, you can always catch us on Facebook and Instagram. Guys, we hope you had a good day. We sure did, and thank you.